Here's example 8 with sum and difference formulas. So we're given the cosine of alpha is -3/5 and alpha is between pi and 3 pi over 2. And we're given sine of beta is 2/3 and beta is between pi over 2 and pi. Okay, and we want to use this given information to determine the sine of alpha, the cosine of beta, and then the cosine of alpha minus beta, and then the sine of alpha plus beta. Okay, so for parts A and B, we've done some stuff like that before. And what we're going to have to use here, we're going to have to use reference triangles. Okay, so let's just go ahead and jump right in and do that. So we want the sine, so for part A, we want sine of alpha, and we don't need to use anything about beta to get anything about alpha. Okay, so sine of alpha, we only need to use cosine of alpha and where alpha is. So we can forget about this stuff with beta right now for part A. So cosine of alpha is -3/5, and alpha is between pi and 3 pi over 2. So before we can start, we have to figure out which quadrant alpha is in. Well, we're pretty much just told right here. So if alpha is between pi and 3 pi over 2, just think about if you have a unit circle, or really we don't even have to have a circle there, but 0 radians is over here. So here's 0 radians, pi over 2 radians is up here, and then pi radians would be over here. So if you go all the way around there, that's pi radians, and then 3 pi over 2 radians would be down here. So that's 3 pi over 2 radians. Okay. So alpha is between pi and 3 pi over 2. So alpha is somewhere between pi radians right here and 3 pi over 2 radians right here. So in other words, alpha is somewhere down here in the third quadrant. Okay. So where is it in the third quadrant? Is it somewhere down here? Is it somewhere over here? It doesn't really matter. The point is alpha is in the third quadrant. That's really all we need to know. So that's going to help us set up our reference triangle. So let's go ahead and draw that. X-axis, y-axis. And here's our angle alpha. And then we'll drop that perpendicular. Okay, so here's the angle alpha. So we'll go ahead and label that different color. Okay, so there's angle alpha. Now let's zoom in a little bit to this part A here. Okay, now there's a couple different ways to proceed, but let's do it a slightly more simple than, well, there's a couple different ways, so we'll do it the easier way, the simpler way. So cosine of alpha is -3/5. So remember, cosine is adjacent divided by hypotenuse if you're in a right triangle. So we have a right triangle here, but we have to be a little more careful because our angle alpha, this angle right here in the right triangle, that's not exactly alpha. This whole angle right here is alpha. However, remember reference angles from way back several videos ago. So this right here, this angle is the reference angle for alpha. Okay. So when we talk about cosine being the adjacent over the hypotenuse, since cosine of alpha is -3/5, then cosine of this reference angle in here is going to be 3/5. Okay. So so we can talk about the adjacent and the hypotenuse relative to this reference angle in here. Okay. So let's go ahead and label that. So since cosine is -3/5, this adjacent side will be 3. Let's get a different color in there. This adjacent side will be 3, and then the hypotenuse will be 5. Okay. Now notice that the cosine of alpha is -3/5, so when we said there's a couple different ways we can proceed, this is kind of where it breaks apart. So one thing we could do is just keep all the numbers positive and worry about the sign, SIGN signs at the end, whether stuff's positive or negative based on what quadrant we're in. But it could be kind of confusing. It's not going to be this bad with just sines and cosines, but it could be kind of tricky if you have more complicated things happening. So what we're going to do instead is label this with a -3. Okay. And this is going to stay a +5. Why is that? Well, first of all, cosine of alpha is -3/5, so one of these two guys has to be negative. Why is it going to be this one? Well, if you start at the origin, here's the origin, you go in the negative direction to get to this point on the triangle, and then here you go down, so whatever's over here is actually going to be another negative number. We have to figure that out. And then the hypotenuse should always be positive. Okay, so you can use this same negative technique in quadrant 2, 3, and 4. You don't need to in quadrant 1 because everything's positive. But in quadrant 2, 3, and 4 you could do the same thing. I think we've done it in an earlier video. I can't remember, so we'll just explain it again. But anyway, the hypotenuse should always be positive, no matter what you're doing. And here we can call this -3 because we start at the origin, go in the negative x direction. So go to the left in the negative direction. So it's going to be -3. Okay. Now if we look at this, if we think about what kind of right triangles do we know, what's a Pythagorean triplet? that we know. So if we have a right triangle, this is 3, this is 5, then this will be 4, right? 3, 4, 5. So it's a 3, 4, 5 right triangle. Okay, so this is going to be 4. Okay. But again, because we're going down, okay, we have to start at the origin, go left in the negative direction. So it's going to be -3. Then we go down in the negative y direction, so that's going to be -4. Okay. And again, do we have to do it like that? No, we don't have to. If you want, you can keep everything positive and then just think about trig functions in terms of the reference angle, and then look at what quadrant you're in, and then use the quadrant to get the positivity, negativity. Okay? Right? And if you're not comfortable with the 3, 4, 5 right triangle type thing, you could just use the Pythagorean theorem. So you can call this y, call that y, and then what you have is y squared plus -3 squared equals 5 squared. Okay? So then y squared plus 9 equals 25. Subtract 9 from both sides, y squared is 16. So then y equals plus or minus 4. And again, we're just going to take y to be -4. Okay, because we have to go down. Okay, so again, start at the origin, go left in the negative x direction, so -3, then go down in the negative y direction, so we have -4. Okay. Okay, so now that's going to give us the sign right away. So remember, cosine is the adjacent side divided by the hypotenuse. So the sine is the opposite side divided by the hypotenuse. So we see that the sine of alpha is -4 divided by 5. So that's our answer, -4 divided by 5. Okay, that's our answer for part A. Okay, and again, if you don't like doing the negative signs inside the picture, you could just keep everything positive. So this will be +3, that'll be +4, and then you'll have sine of the reference angle is +4 over 5, and because we're in the third quadrant, sine of alpha, the entire angle alpha has to be negative because alpha's in the third quadrant. Okay, so then you'll actually have -4 over 5. So it is sort of an extra step there and another thing to remember, but it's really not a bad way to go. It kind of helps reinforce earlier concepts. But anyway, it does. If you do it like this, it's kind of it's a little bit better because it's less likely to make a mistake, or less steps to make a mistake in. All right. Anyway, so that's part A, -4 over 5. So part B is pretty much going to be the same way, but now we have to use beta. So nothing about alpha, just beta. Sine of beta is 2/3, and pi over 2 is less than beta is less than pi. Okay. So again, just like before, we have to know which quadrant beta is in, and this tells us right away. Well, if here's pi over 2, here's pi, so if beta is between pi over 2 and pi, then beta is somewhere up here in the second quadrant. Okay, where in the second quadrant? Is it over here? Is it somewhere in here? Is it over here? It doesn't really matter. We don't know. We don't care. All we care about is that beta is in the second quadrant. Okay. So let's go ahead and set up our reference triangle. X-axis, y-axis. And then here's our angle beta. Okay. Now we're given that the sine of beta is 2/3, but again, remember that in a right triangle, sine is opposite over hypotenuse, and it's kind of weird to talk about the opposite here. But if this is the angle beta, then this angle right here is going to be the reference angle for beta. Okay, so this right here is the reference angle for beta. And when we talk about opposite and adjacent and hypotenuse, we can talk about that relative to this reference angle. So since the sine of beta is 2/3, then what we can say is this will be the opposite because it's opposite the reference angle. So this will be 2, and then 3 is the hypotenuse. Okay, so sine of beta is 2/3, so sine of beta is opposite divided by hypotenuse. So opposite over hypotenuse, 2 over 3. And I do want to point out that that's not the only way we could set up this triangle. There are other ways we could label it using the given numbers, but this will be the simplest way here. So 2 over 3, opposite over hypotenuse. That's one way of doing it, probably the best way, just to avoid fractions, or messier, nastier fractions rather. Okay. Because things like 2/3, -4/5, -3/5, those aren't too bad. Things could get a little worse if we try to complicate it more than it needs to be. All right, anyway, so, and this is going to be using the same kind of thing we did in part A. We're still going to have +2, because if we start at the origin, we go in the negative x direction, so whatever we put here is going to be a negative number, okay, if we stick to what we were doing. And then we have to go up in the positive y direction, so this should be a +2, no matter how we do it. And remember, the hypotenuse is always positive. Okay, so here, so 2 something and then 3, that's not a nice Pythagorean triple, so we have to use the Pythagorean theorem. So x squared plus 2 squared equals 3 squared. So x squared plus 4 equals 9. X squared equals 5. So then x equals plus or minus square root of 5. And again, we're going to take the negative square root because if we start at the origin, we have to go left in the negative x direction to get to here, and then up in the positive y direction. So since we go left in the negative x direction, that's going to be negative root 5. Okay. And again, we don't have to do it like that. We can just keep everything positive and then think about everything in terms of the reference angle, and then just use the fact that we're in the second quadrant to make sure that cosine is negative and sine is positive, things like that. Okay. So anyway, well now since we have the side labeled, we can just right away get the cosine, and the cosine is the adjacent relative to the reference angle divided by the hypotenuse. So the cosine of beta is negative root 5 over 3. And that's our answer for part B. Okay. And that's actually the bulk of the work for the problem, because for part C and D, we want the cosine of alpha minus beta and the sine of alpha plus beta. And this is pretty much just straight up plugging numbers that we already have into a formula. Okay. So cosine of alpha minus beta, what's that going to be? So if we don't have that memorized, we can pull out our formula sheet. And if you want a copy of this, you can check the video description. There's a link in there. Click that link to get a copy of this. So cosine of alpha minus beta. So we see that cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Okay. So, oops. Cosine alpha cosine beta plus sine alpha sine beta. Okay, so that's 4 different numbers, right? Cosine alpha cosine beta and then sine of alpha sine of beta. Well, we have all 4 of these. Okay, we were given cosine of alpha and sine of beta, and in part A we found sine of alpha, and in part B we found cosine of beta. So we know what all 4 of these are, so really we're just multiplying 4 numbers that we already know. Or multiplying 2 numbers and then adding them to another product of 2 numbers. Anyway, so the point is we're just plugging numbers into a formula, numbers that we know. So cosine of alpha we know, we were given actually, is negative 3 over 5. And cosine of beta we found in part B was negative root 5 over 3. And then plus sine of alpha we were given, or sorry, no, sine of alpha we found in part A is negative 4 over 5. And then sine of beta is what we were given, that was 2/3. Okay, sine of beta is 2/3. Okay. So when you simplify this, you might be kind of tempted to cancel these 3's over here, but it's probably best to leave them so that we can get a common denominator here. So actually, we already have the common denominator, and it's 5 times 3, which is 15. So this negatives multiply, they cancel. So what we have is a 3 root 5 over 15, and then plus negative becomes minus. 4 times 2 on top is 8, and then 15 on the bottom. And then we can just squish it all together into one fraction, so we have 3 root 5 minus 8, all divided by 15. And that is our answer for part C. Okay. So again, a little simpler than part A and part B, because in part A and part B we had to use reference triangles there, and worry about those little subtle details with what's positive, what's negative, things like that. But for part C, we're just plugging numbers into a formula. All right, so part D was sine of alpha plus beta. Okay. And if we go back to our formula sheet here, sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. So this is sine of alpha cosine of beta plus cosine of alpha sine of beta. And again, it's the same 4 numbers, just kind of in a different order here. So sine of alpha we found in part A, it's negative 4 over 5. Cosine of beta we found in part B, it's negative root 5 over 3. And then we have plus. Cosine of alpha we were given is negative 3 over 5. And then sine of beta we were also given, it's positive 2/3. Okay? And again, just like before, let's not cancel these 3's here. We'll just leave everything as it is so that we have our common denominator. So, and our common denominator is going to be 15 again, so we'll just put everything over 15. Okay. And then here, negative 4 times negative root 5, that's positive 4 root 5. Nothing else to be done there. And then this is going to be plus negative 3 times 2. So plus negative becomes minus 3 times 2 is 6. Okay. So that's pretty much it. 4 root 5 minus 6, all divided by 15. And that's our answer for part D. 4 root 5 minus 6, all divided by 15. Okay. So that's example 8 of using the sum and difference formulas to evaluate some trig expressions. And here are our answers again for parts A, B, C, and D.